Alright, welcome to Math 300. This is the very first section that we'll be doing, section 12.1, and we're starting in chapter 12 just because I thought it would be great to start looking at some statistics first. So these videos that I'm creating are meant to supplement what the publisher has already done and what you have access to in my math lab. It's meant to give you some personalized instruction, and ideally it'll be a nice supplement to the things that you have already had an opportunity to read or to look at, and could ideally provide just a strengthening of your understanding. And so what's happening in this first section is we're looking at visual displays of data. So as you know, statistics would be collecting a lot of data, and there's some things that we'd love to be able to do with it. One is to organize it, and that's what this first section is. And there's some ways that we're going to organize data and get a good picture of what it looks like. One way to organize it is through a frequency table, and another is through what they call a stem leaf plot. Stem and leaf plot is what it's most commonly called. Both of those are addressed in this section. From the frequency table, we can get graphs of data known as a histogram. And then we could also get what they call a frequency polygon, I think is the way our book calls it. And all of these are addressed in the homework, and so I wanted to give you some examples of these. And so what I did is I pulled example number 9 from our book, and it has the 48 scores on a 50-point exam from a sociology lecture. And so as we talk about the very first one, let's talk about frequency tables. And so I'm going to just focus on frequency tables. I'm going to come here and erase these other words that I put out there. And a frequency table is essentially what it says, a table that organizes the data. It organizes the data into usually uniform classes. And what I mean by uniform classes is that they're the same width. And so it's going to take this data and break it down into categories. And we'll usually get some direction on how to create those classes. If we don't, then we kind of make them up ourselves, trying to capture at least 5 classes as we go through there. So as we look at this, I typed in the directions that were in the homework right below. And so if you look below the picture of the data, it says for the frequency table, use a uniform class width of 5, where the lower class limit of the first class is 21. And so what they're asking us to do is start with the number 21 and go and have a class width of 5. So the class width tells me how to travel from one class to the next class. Not where the first class ends, but where the next class begins. So my next class is going to begin at 26. So my first class is going to go from 21 to 25. And my next class is going to go from 26 to 30. And so you'll keep building this by adding 5 each time. Now notice that first class does have 5 distinct values: 21, 22, 23, 24, and 25. So it does have a class width of 5. But the class width tells me how to travel from one to the next. So 26 plus 5, well, that's 31. 31 plus 5, 36. And I know when to stop when I don't have any more data. So 36 plus 1, 36 plus 5, 41. 41 plus 5, 46. 46 plus 5, well, I'm going to exceed that. That's going to be 51, and I can't have 51 because if you remember, it's a 50-point exam. And so I can stop there. So I'll go ahead and come in here and erase that 51 and come back to say 31 to 35, 36 to 40, 41 to 45, and 46 to 50. So that is what my frequency table starts at. So we know what these are, and you can label them as such. Sometimes they put classes, but it's most likely better to say score on the exam, right? And we're going to do is get a frequency. We're going to count the number of numbers that are between 21 and 25. So as I go to the first row, there's none. Second row, there is one, the number 23. So I at least have one. And our book demonstrates that you could do a tally. So if I start to do a tally, I got one. Nothing in the third row, nothing in the fourth row. Whoops. Nothing in the fifth row, nothing in the sixth row. Right. There is a 28 there, but it's not between 21 and 26. And so it looks like I just have one in there. And I'm done with that first tally. Then as I go to the next row, I'm interested in numbers between 26 and 30. So I'll make this big again. Nothing in the first row, nothing in the second row. Looking for 26 to 30. Nothing in the third row, fourth row. I have a 29 in that fifth row and a 28 in the sixth row. So it looks like I have two. And so I'm going to put a 2. And you're going to just keep doing that. You're going to go count the 31s to 35s. And I pre-counted it. There's 5 of them. 46 to 30. I'm sorry, 36 to 40. There's 12. 41 to 45, I counted 16. And 46 to 50, I counted 12. So it's a little bit of busy work, but you start to get an idea of the distribution of the scores. There's more scorers in the higher realm from 36 on, right? And you can kind of see that here, but this gives you a nice physical count. So this is what we call a frequency table. Sometimes they'll ask for the relative frequency table. And the relative frequency table is asking for the percentage. And so if you're ever asked for a relative frequency table, what that does is it tacks on to a frequency table. So you'll get your frequency table first, or it will be given to you. And then you run the percentages. Now, how are we going to get the percentages? Well, remember, there's 48 exams, right? If I totaled the 1, the 2, the 5, the 12, the 16, and the 12, it should total 48. I'm just going to double check that I counted right by adding all those up. It does. It totals 48. So the sum of these frequencies totals 48. Move this up a little bit so you can see that 48. So 1 out of the 48 was in the first class. So if I take 1 and divide it by 48, I get about 2%. And you'll do some natural rounding there. You could do 2.1%, 2%. I'll do 2.1%. I'll go out to the 10th of a percent. But if you did 2%, you'd be fine. 2 divided by 48 would be the next one, right? And that would be about 4.1%. Or actually 4.2% if I round correctly. 5 divided by 48 is 10.4%. 12 divided by 48 is 25%. That makes sense, right? Because 12 is a quarter of 48. 16 divided by 48 is 33.3%. And 12 divided by 48, we know already, is 25%. So that's what they mean if they ever ask for a relative frequency table. They want you to find the percentage. And I believe it's in our book as we go through. From a frequency table, we can construct what's called a histogram. And a histogram is a bar graph of a frequency table. And so I'm going to get this storage full thing every once in a while, so I apologize for that. So a histogram is going to be a bar graph of this frequency table. We're going to try to visually display it, and the y height of it is going to be the frequency, and along the bottom will be the test scores. And so the way our book does it, I was flipping in the back to make sure I was going to do it right. They're going to say, hey, this is 21 to 25. And they're going to draw a bar graph up the height of 1. I don't care so much that you label out. I'm sorry, that you scale this. Just make 1 smaller than 2, smaller than 5. So twice as high for the next category would be from 26 to 30. And then the next one would be the 5. This is 31 to 35. And then you're going to go super high, right? 12, and then 16, and then back down to 12. And you get a nice visual display of the data. Labeling each one of these, right? I apologize, I'm kind of constrained in this, more constrained than I thought I would be when I started this. So this is 36 to 40. This one right here is 41 to 45. And this one right here is 46 to 50. So that's all there is to a histogram. You're just drawing a bar graph of the frequency, right? Where this is the frequency height of 1, 2, 5, right? Up here would have been 12 and 16, right? Coming across the top. And the point is you get a nice picture of that data. A frequency, I'm sorry, a polygon, a frequency polygon, does something interesting. What it does is it says, well, how am I traveling? And so it'll have a XY plane like that, and we're doing a plot, a dot plot, basically a numerical plot. And the way that you do your frequency polygon, apologize, I dropped the wording, is you go and put dots instead of these bars. And so the question is, if you have a whole range of values, 21 to 25, where do you put that dot? And that first dot comes at the average. What's right in the middle between 21 and 25? Maybe you see it, but if you don't, you can add the 2 and get 46 divided by 2, or 23. So they're going to use the point 23, comma 1. So they'll just name this point as 23, go up what you call a height of 1, and put a dot. Now the next one is going to be 5 later. So we can do the 26 plus 30 divided by 2, but what if we just added 5? That should be the next midpoint. That's what we call that. We're taking the middle of each class, or the midpoint of each class. So 23 plus 5 is 28. Well, at 28 I was up at a height of 2. And then plus 5 is 33. And at 33 I was up at a height of 5. And then plus 5 is 38. And there I was way up at a height of 12. And then 38 plus 5 is 43. And then I'm up at a height of 16, even higher. And then one last one at 48. And we're back down to a height of 12. Right? So that's what a frequency polygon looks like. And what happens is we connect the dots in those frequency polygons. We're going to start right here at the 23 and go up, 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 and you're just basically doing a dot connection to each one of those dots. And some books would have you leave it like that. Others will have us change it a little bit. Let me see what ours does by flipping to the back of the book. So for this guy right here, they're going to have us kind of just tail off and tail down. That's more what you see, is that it will come down, and you can drop it straight down. Don't worry about the angle of these, but that's what the frequency polygon looks like. And so these are the main things that you're doing in this, is you're creating these frequency tables, this histogram, and this frequency polygon based upon what you see in the given set of data. So as you have questions or concerns, just email me. I can post up more videos of specific problems that individuals are having problems with. But This should be a nice core anchor for most of the problems in the 12.1 section.